Hi, I'm Kathleen Lyon of the American Museum of Science and Energy, and today we're going to learn about electricity and magnetism. First of all, we need to know what an electron is to understand electricity. Let's take a look at the atom. We see that the nucleus is composed of positively charged protons and neutral neutrons. Outside the nucleus, electrons move not quite like we see here, but they are moving. And sometimes electrons can come off and travel other places. Conductors allow electrons to travel, whereas insulators stop electrons. They don't allow them to travel. So today when we make electricity, all electricity is moving electrons along a conductor. Now let's see if we can move some electrons. Our source of electrons will be a battery. Electrons have a negative charge, so we would say they come from the negative end of the battery, or the flat end. That means the end with the little hump on it, that's the positive end of the battery. So electrons are going to travel from the negative end of the battery. They somehow need to make it back to the positive end of the battery, but there has to be a pathway for them to travel on. And ideally that pathway will take them to something useful so that we can see the electricity is making something work or something turn on, like a light bulb. So what we need now is a conductor, a pathway on which electrons can travel. And our pathway will be made of aluminum foil wire. And if we put one end of the aluminum foil wire underneath the battery and one touching the very bottom of the bulb, the electrons have come this far. This section is metal. The electrons inside, though, can travel up a little wire and go over this loop, and they're going to come out the side. From the side of the bulb, we can attach another aluminum strip foil and make a path for the electrons to travel to the positive end of the battery. So electrons have traveled into the bulb, through the bulb, back to the battery. The electrons have gone in a circle, so we call that a circuit. This is difficult to hold together if you only have one person at work, but if you have two people, they can kind of help you hold everything in place. Also, notice that the wires are not touching each other. So now let's take a little bit closer look at what's happening. As the electrons travel over the top portion of this wire inside the light bulb glass, there's an area here where the electrons meet resistance. Resistance means the electrons have difficulty pushing their way across that portion of the wire. Imagine if I were walking through this room right now, and walking through the air, it's very easy for me to move back and forth across the room. But if I try to walk back and forth in a pool of water, it's more difficult because there's more resistance against me as I walk. But that's what's happening to the electrons here. They're having a more difficult time, heat builds up, and also, not only is heat given off, but light. And so the resistance makes the light come on. And our light is glowing, and our circuit is doing well. Sometimes you'll try to set this up and it won't work. This could be what's happening. If you let the wires touch, because they're not insulated, that means they don't have a coating to keep the wires from touching each other, the metal parts from touching each other. If they touch in the middle, this is what happens. The electrons travel from the negative end of the battery, they travel along to this point, and then why would they go this way and meet resistance when they can take an easier route and go back to the positive end of the battery? So they do this. Notice the bulb goes out, I've made a short circuit. Also, the wires get hot, by the way. If your wires are getting hot, you have made a short circuit. It's not going to feel very comfortable for you, and the bulb is not going to come on, and the battery is going to drain. So those are three bad things that will happen. Let's go ahead and try to make our light bulb come on with one battery and one wire. So these aluminum foil wires, by the way, literally a sheet of aluminum foil folded over and over again until you reach the desired thickness. This time, we will use a battery once again. Our electrons flow from the negative end. They're trying to get to the positive end. We want them to go through the bulb. We're going to set the bulb right on top of that battery. Now we move our electrons along our pathway using one wire. Electrons travel from the negative end of the battery, along the wire, in the side of the bulb, over the loop, and out the bottom. So the electrons can go in the side and out the bottom, or in the bottom and out the side of the bulb. Doesn't matter which way you go. Light is produced, and the electrons have arrived back at the positive end of the battery, so we know we have a complete circuit. Even though there's not two wires that can touch one another to make a short circuit, you can run into another problem. There's still a way you can make a short circuit. So I know what you're thinking right now. You're thinking, what if we added more power, more batteries, more voltage? Let's try it and see what happens. There's a couple of ways we can do it though. First, we're going to add batteries in series or in a row. First, let's put 2 batteries in series. Our bulb goes on top. So we can take a single wire and attach it to the negative end of the battery and connect to the side of the bulb. Now the electrons are traveling from the negative end of this battery around, going in the side of the bulb, over the loop, out the bottom, and they've arrived at the positive end of this battery. Notice that the positive end of this battery touches the negative end of this one. So negatives travel to positives always, and our light comes on. And I think you will notice that it's even brighter now. We have more voltage because we have 2 batteries. Now, try doing the same activity, adding a 3rd battery. We can also add batteries in parallel. Let's see what that looks like. Just like series means in a row, parallel has a meaning also. It means side by side. Let's start with 2 batteries in parallel. And our bulb will be over here. One wire needs to go across the top and touch the side of the bulb. One wire should go across the bottom and touch the bottom of the bulb. It's very, very easy to let these 2 wires touch, but as we have already found out, if those wires touch, we're going to make a short circuit, something we don't want. Right now, even without a bulb, these wires are getting very hot on my hand because the wires are touching, so we have a short circuit at this moment, and my fingers are starting to get a little warm, so we're going to break that circuit. Instead of getting the full voltage going to the bulb, you only get a fraction of the voltage for each battery in parallel. And you probably could tell that this is what's happening because, as you can see, the bulb does not get as bright with batteries in parallel as they do when they're in series. But you say, what if I put another battery in, 3 batteries in parallel? Well, you can do that. This starts to get a little tricky. This is a good time to have a STEM friend if you have someone nearby to help you hold things in place. The bulb gets a little brighter, but still not quite as much. Remember, when we add batteries together in parallel, you're only getting a fraction of the voltage each time you add a new battery. If you put them in series, they add directly. So if you have probably more than 20 batteries and you can find a way to hold them all in series and connect it with some wires, you can actually make a large light bulb come on at home. You can give that a try.